Okay, so let's take a look at this one here. We are going to need to check charge, baryon number, and strangeness. Okay, so let's do that. Okay, well, here we go. Okay, I feel like I need to do that too. So a proton is down here, right? So proton is a proton is not strange, has a baryon number of 1, and also has a charge of 1. So this is 1 plus 1, right? And then on this other side, here's the other side of the divide here. This is 1 plus 1, right? And this is 0. This guy here, we don't even have to look it up, right? In fact, the charge isn't even in the table, okay? But the fact that it's got a plus there means that it's a 1. And then the fact that this has a 0 there means that it's 0 charge. So these little pluses and zeros, those are charge. The proton doesn't have a plus by it, although some people do. They'll put a plus by it. And then the P minus is the antiparticle. Fair enough, okay? Some people do that. I don't, but I think you know that a proton has a +1 charge, okay? Let's look at baryon number. So protons are 1. We also have a neutron in here, right? And neutrons are also 1. Right, so baryon number, we've got 1 and 1, and a proton is 1, and that's 1. Let's look at this. This is an anti-sigma plus. Let's find that. There it is. Okay, well, it's the antiparticle. It's this one here, right? Okay, so that one is going to be a baryon number of -1. Because the baryon is +1, the antibaryon is -1. Okay, and then let's look at our lambda naught. And the lambda naught is the matter particle. Okay, so that is a +1. So to me, it looks like charge works, right? We have 2 = 2. Baryon number works. We have 2 = 2. Let's look at strangeness. Okay. Now notice that neither a neutron nor a proton is strange, right? So there's no strangeness there. Okay, but let's look at this anti-sigma plus. Well, the matter particle is -1, but the antimatter particle will be +1 because all the numbers are reversed for antiparticles. Okay, then let's look at our lambda naught. Well, that's the matter particle, and it is -1. So to me, strangeness seems to work, right? So I'm going to give this my nod of approval. Unless there's some other conservation law that I just don't know because I'm teaching like particle physics light, this reaction could occur. The fact that there's much more mass on this side isn't a problem because the kinetic energy of these protons from the particle accelerator they came from could comprise that, right? That's the notion, right? That's what particle accelerators are for, is to create more mass, right? Notice that these particles have short, very short half-lives. You can look them up here, right? So they exist hopefully long enough to get into the detector.